Complexity Live. This is a collaboration between HumanCurrent and Complexity Labs. And this will be a live discussion for just short of an hour. And we have amazing guests with us. And we'll introduce those shortly. While our conversation is going on, there's also a live chat that's happening, and Haley will be monitoring that.
Mhm.
Meanwhile, I'll be monitoring the discussion that we're having, and Joss has joined us as well with Complexity Labs. And I'd like to start off with you, Joss. Can you give a quick little intro and tell us what Complexity Labs is?
He's muted. Oh, there you go.
Sorry, 1 second. There I am. Okay, Complexity Labs. We're an online platform for complex systems. We produce educational content, videos, articles, research, and so forth. And I run the website. And you're probably familiar with me if you're watching this channel, so I'll pass it on to everyone else.
Thanks, Joss. And I know that you're having some technical issues over there with some blackouts and stuff, so we hope we can keep you on the whole time. And that's why we can't see your face right now. I'm glad that you're able to be with us. I'm going to pass it over to my co-host, Haley, if you could do a little intro of HumanCurrent.
Yeah. So we're the HumanCurrent podcast. We are the Complexity podcast, sharing stories and casual conversations about complexity science and systems thinking. And we also have this collaboration with Complexity Labs. And we're happy to partake in this conversation today.
Today, we'll be discussing building networked organizations. For example, how we can use new information technologies like blockchaining and AI to build new forms of networked organizations. And we have Trent McConaghy. Oh, hey, there's Joss. We have Trent McConaghy with us. He's the founder of Ocean Protocol, a decentralized substrate of AI data and services. We also have Michael Zargham. Give a little wave there. He is the founder of BlockScience, a technology research and analytics firm specializing in the design and evaluation of decentralized economic systems. And hopefully we will also have Diego Espinoso. He's trying to get on right now. And so if we see him pop up, he writes on complex systems, networks, and blockchain. He has launched 3 blockchain-based ventures, including a Web 3.0 data sharing protocol. We're also hoping that Mahela Ularu can join us. She is a chief alchemist at Endure, and so hopefully she'll be able to join us too. She was also a blockchain champion at the World Economic Forum, where she advocated to be listed on the 2016 top 10 emerging technologies developed in American. And Michael, I believe you know her as well. Small world. So we're going to kick off this discussion. I want to also welcome those that are joining us online for the live discussion, and Haley will be monitoring that. Every so often we'll pop over there and see if there's something exciting happening over there. I want to kick off the conversation, open it up to Michael and Trent, and if Diego and Mahela are able to join us, we'll also pass it over to them. And start us off with talking about how your work relates to building networked organizations. And how about we start with Michael?
So my work actually focuses on the various layers of systems that sort of need to come together in order to sort of build a system that adds value in the real world. So blockchain is a really exciting technology, but it's essentially a lower level sort of baseline. And the way that I like to think about it is blockchains are sort of like semiconductors. They provide the substrate, then we start building smart contracts. They allow us to sort of have microcontrollers. They allow us to make things, but it's really what we make out of them that leads to sort of human level value. And a lot of my work focuses on both the layers it takes to get from technology to human value, and then sort of once you acknowledge those layers, what we need to develop sort of systems thinking wise and sort of mathematical tool wise to actually accomplish the full stack.
Oh, that was interesting. Thank you for that. And how about over to you, Trent?
Sure. Hi, guys. Thanks for having me here. It's really fun and a pleasure. So overall, Ocean, the main focus of Ocean is it's a little bit a bit about building networked organizations, but it's more like Ocean itself is a networked organization, or perhaps better put, a networked organism, as in, you can view it as its own sort of life form living on the internet that is taking in input from people. People are running resources, running nodes of Ocean, etc. We're getting some bad feedback here from someone. Okay, this thing
Yeah, we're
should go
getting
away.
that as well. I'm not sure.
Oh, he's on mute now. Is he?
I'm not sure who.
Yeah, let's see if I go on. Interesting. Okay. Okay, it's better now. Maybe that's the internet listening in and trying to squish me. Another organism. So overall, there's a whole bunch of different ways to frame blockchains. Everything from just a very, very simple database with extra features to sort of higher and higher level stacks, and they can be viewed as sort of semiconductor level technology, and that's a very good framing, like Zargham put. But they can also help to unlock higher and higher level capabilities. And Ocean is really about capabilities with respect to data and AI. If you're building AI systems these days, especially the ones for classification and regression, building models like deep learning, those systems need lots and lots of data, and it's really, really hard to get data. So Ocean incentivizes the supply of the data by a few different mechanisms. One of them is block rewards that reward you if you supply relevant data to the network, as well as things like privacy preserving compute and all of this. And overall, this is within the context of Ocean itself as a networked organization doing this. So it's just kind of out there on the internet. No single entity owns or controls it. Rather, a bunch of humans or bots are running nodes, and collectively it's providing this public utility type functionality to the internet.
One thing I find that's really interesting about Ocean, just from my conversations with Trent and his team members, is that it sort of has two levels of AI happening at the same time. It's enabling AI in the sort of traditional sense that we see in the big tech companies today. It's democratizing it, but it's actually itself more of a collective emergent AI. And so we get to see the two sort of types of AI that are important in the world sort of meet in this one solution, which is pretty cool, in my opinion.
Agreed.
Yeah, Haley, you have a question?
I'm curious, how do you incentivize people to join this network or to become a part of it? And how do you get people aware of it? And where does that start, just to get the ball rolling?
Yeah, so this sort of, get the ball rolling and then sort of towards equilibrium. And the get the ball rolling is, it's a lot like traditional startups in the sense where you just kind of have to get out there, get out of the building and walk around and talk to potential users. So in the case of, and then once you're there, equilibrium, it's more around block rewards and other reasons that people stick around. So for the first part, what we're doing is Ocean itself, you can view as a multi-sided platform where there's suppliers of data and then consumers of data. And so we're finding places where there's problems that people are trying to solve where Ocean can make a big difference, and sort of like one tribe at a time. So one sort of problem tribe, if you will, is the people trying to build autonomous vehicles, especially the big automakers, the Toyotas, the GMs of the world. And they all see that they have, the algorithms that are pretty good for the self-driving cars, but the accuracy is not good enough. And they see that they need 500 million miles driven in order to get the accuracy they need. Sorry, 500 billion. So 3 more orders of magnitude. It's a lot. So for these automakers, we're talking 20, 30 years worth of their own running around. But if they actually were to pool their data somehow and merge it, then they could actually ship this technology much, much sooner. So Ocean can help them to pool their technology together in a way that preserves privacy issues and helps to incentivize them to just work together on this such that they can all ship their self-driving car technology much, much sooner. So that's one example. Another example is with building models for prediction of medical issues, things like Parkinson's, cancer, et cetera. And more. So it's sort of one problem at a time, helping on the supply side, helping on the demand side of data, and then building the models. And then ultimately, though, that's really to sort of kickstart it to get the sort of baseline usage. But overall, then equilibrium is more about the block rewards. So with Bitcoin actually is trying to incentivize people to use Bitcoin by saying, I have an objective function in a classical optimization setting, which is maximize the security of the network. It defines security as hash rate, and it pays you in Bitcoin tokens if you contribute to the hash rate. So if you had contributed say 10% of hash rate to the network in the last 10 minutes, then on average you can expect 10% of the block reward, or 10% of 12.5 Bitcoins. That's the expected gain. So overall, it's paying you to add to the security of the network. That's what it's maximizing in security. In Ocean sense, it's paying you if you add relevant data to the network. And once again, it's using inflation, sort of printing tokens, and then giving that to the users who are adding value to the network in terms of relevant data. So, going back to Zargham and stuff too, this is something that he and I realized and iterated a lot on, of realizing that at the heart of these systems, you can design these systems as if they are optimization problems. And then you can draw in all this learnings from, you can call it subfields of complex systems, whether it's, classical operations research, whether it's evolutionary algorithms, et cetera. All of these learnings and ideas can actually be drawn into the world of designing tokenized ecosystems.
So one of the cool things about Ocean is one example of a network that's actually incentivizing a form of peer production, right? And there's a broader class of problems. Again, I work on sort of abstracting the ideas of good solutions and creating new solution patterns and tools for analyzing them. This issue of peer production is actually central to networked organizations. That fundamentally there isn't a centralized entity orchestrating production, but rather the notion of production is sort of implicit in the network, and that whatever rewards, whatever incentivization is being created, that it ties back to some production, which immediately results in a question of how do we measure production? In Ocean, it's relatively straightforward, as Trent described it, because it's contributing data that others find useful. But in a general sort of decentralized network, the question is, what does it mean to provide some form of production or capacity or resource that the networked organism, so to speak, or ecosystem is needing or consuming? And so we have a couple other areas of research with my team relating to data models and how we create sort of clear representations of production, especially when the ultimate value is several hops removed from some form of production. A simple example would be in a world where you have researchers and then designers and then testers, and then an actual piece of software gets deployed, and then that software is used to provide some form of production. Like, how do you reward the production back down that chain if it was all necessary to realize the community value? And so this notion of sort of secure, sort of event-based or sort of linked data models is part of our research. And then, in fact, questions about building incentives for that production on top of that layer becomes a recurring pattern in some of the system design and testing problems that we face.
Yeah, and maybe just to riff on that just a bit more too, how Zargham put it, the fact that given that this is decentralized, you can't kind of approach it in a super direct sense in the traditional engineering fashion. And really what you're creating is an economy, right? So then, if you're designing an economy, what does that look like, right? And, there is ideas from classic, mechanism design and all that. So how do you combine ideas there around game theory and so on with ideas from engineering, with what we've been observing in the world of blockchain? How do you design an economy ultimately? And that's actually kind of a big question, and we're starting to have answers, but it's super early days. It's a fascinating question though, because you can involve people from all these different fields, whether it's economists or complexity scientists or otherwise, right? You can view it as an agent-based system with its own economy, right? And then, what are the roles of the agents? What sort of agents do you want? What sort of behaviors are they allowed to have, et cetera?
From a complexity science perspective too, what's interesting is that you immediately realize the interaction effects between the mechanisms you design. So traditional mechanism design problems are like, here's a mechanism and here's a set of behaviors, and you're sort of engineering this one component. And the complexity science question that immediately arises, okay, but now I have n groups of behavior types and agent types, and I have n mechanisms, and I have some M mechanisms, and then I have some other set of state variables in the system that I care about. Suddenly I have a very high order interaction effects system, and it's not actually the component designs that drive the system's behavior. It's actually the interaction effects between the various mechanisms, the various behavior types, and the various sort of state variables that we use to represent the system, as we define the objectives, as we define the constraints. And a big part of my work has been to formalize that. I think we discussed at ICCS briefly my paper on state space models and the sort of advancements that my team has made around CAD tooling, which I've recently shared with some members of Trent's team, because ultimately the complexity level is so high that we can't, even with good analytical tools, reason forward and say, oh, here's what's going to happen. We need to do analytical work and follow it up with numerical testing and iterate the design, because ultimately, we don't want to put a society type system or a community type system into production without some strong, understanding of what might happen.
I have a ton of questions as you and Trent were talking that came to mind, and the one that comes just after what you're just talking about was, how do you even navigate all of that, and how do you and your teams make sure that you don't fall into the reductionist mechanistic ways that we're, as humans, I think, in a society is kind of programmed to do. Yeah. So how do you how do you navigate all of those complexities? I'm thinking of, this being global, and so clearly that increases the complexity, and the world continues to move forward, and so you're trying to do work over here, but things move forward. So how do you navigate so much complexity at a global level, and then also creating a system and not falling into the mechanistic reductionist ways that we're kind of programmed to do? That might be a big question.
It's a piece of cake.
Could I jump in there for a second?
Yeah.
Sorry. Well, I think that's a great conversation. You're really kind of connecting stuff from blockchain into complexity theory. I mean, I think it's really about the idea of evolution and initial conditions, and the idea that you can't, in a centralized system, right? Everything's kind of linear. You can control that you can affect that component in the center, and that affects everything else, right? And that's our traditional way of thinking. But without that, the whole point of the blockchain is decentralized, right? And you haven't got that anymore. So all you can actually do is kind of what you're saying. All you can do is actually set the initial conditions, which is the incentives in the tokens, right? And then let evolution take its the feedback loop, selection and evolution, take the system wherever it goes. And then obviously you can get data back, and you can readjust those initial conditions. You can try and change the incentives of the systems change the incentives through that token. But I think that's kind of the central issue, isn't it? When you have a decentralized system, right, an economy, as you're saying, Trent, that's a market, that's a decentralized peer-to-peer system. You haven't got that centralized component anymore, and you no longer have that traditional way of kind of linear imposing order on the system, and it's really, it's as David Snowden says, isn't it? You can't actually control a complex system. All you can do is create the context for emergence, for evolution. And that's exactly, I think, the terms that you're using there, that's exactly what you're saying, wasn't it?
Yeah, so exactly. So maybe I'll respond to both points here. So a really nice way to frame it, yes, the overall system itself is super complex, but you don't design that, right? You design something with a small rule set, and you let the complexity emerge, right? So very much like classic cellular automata, for example, right? It's got very simple rules, but then you can see a lot of complexity emerge. Or, and that's one of the very hearts of the ideas of complex systems movement in general. And a very nice example is with Bitcoin, right? So with Bitcoin, it's got this very, very simple objective function at the heart, right? It pays you in Bitcoin tokens if you add to the security of the network. And from that, we've seen the emergence of all these miners and all these wallets and all these exchanges, and sparking the whole blockchain revolution, et cetera, et cetera, et cetera, all from one simple piece of software that just got put out there, right? And shared on a mailing list. So so that's kind of amazing, right? Also slightly scary. That said, like you mentioned, the initial conditions matter a ton, but you do have at least an option to intervene a little bit by changing incentives via on-chain governance or hard forks if needed, right? So that's pretty useful. In terms of designing this then, I spend a lot of time in the world of designing evolutionary algorithms, especially genetic programming, which is sort of like, among the most general, right? Because you're evolving computer programs, Turing complete AI, if I was going to talk to that about, to a blockchain person, right? Just like we have Turing complete blockchains, well, GP is Turing complete AI in a sense. And with that, right, it was about trying to figure out like what's the design space that you're letting evolution happen in, and then like what, and in that sense, you can frame it as a grammar, or you can frame it as an initial design that on which you perform operators, variants of crossover, variants of mutation, etc. And then you do have this evolutionary loop where you have say 1,000 individuals in each loop. They mutate and they change and so on. And then the ones that stick around are the ones that keep getting fed or don't die, at least, right? And it's very, very similar in blockchain land where, basically the agents that really matter are the miners. And if they're adding value to the system in a way that the system likes, then it will feed them by giving them tokens, right? Or it will slash them if they act badly, for example. So it's actually very, very similar in that sense. And so what that means then, though, is that people, if you want to look at design, to me, among the people who can be really, really good at designing tokenized ecosystems are the people who have been designing evolutionary algorithms, right? And the good thing is there's a lot of them who've been around over the years, right? Who have got tons of insight, many of them doing it for 10, 20, 30 years, right? And that's pretty exciting. And just like, we've been sharing, Zargham and I and others have been sharing our insights with the complexity world. We've also been sharing our insights with the world of evolutionary computation because, myself, that's where I spend a lot of time. So it's fun to kind of go back and hang out with my friends from that world and say, hey, here's what's up. This is a whole new tool for you. It's a whole new substrate. And this is no longer simulated evolution. This is evolution itself because, well, at the heart, you can't turn it off.
It's a little funny. I came through a full loop on evolutionary algorithms because I worked on actual annealing of metals before I was introduced to simulated annealing, and now we're building systems that are the digital equivalent, but they're actually live systems. I wanted to talk a little bit about how you create some sort of structure in the way these systems evolve, and it comes through this notion of feedback paths. So these systems, if they're stateful, if they have some internal state that is influenced by the action of the agents in the system, it's possible to then sort of design these protocols or these algorithms to have some dependence on that state. And when the outcome of the action of an agent inside of an evolutionary system has some state dependence, we get a property that's sort of mirrored in the physical world, right? Like I throw you a baseball, I don't have it, you have it now. The sort of space of actions that can occur among agents is limited by some natural laws. And so, in my work, when I'm trying to bring sort of the systems engineering and decision science and collective behavior background, I started as I moved from, actually, I worked on aerospace materials when I was very young and switched over to algorithms. I worked on bio-inspired models for robotic coordination based on bird flocking. And one of the things that we did with that was we had these real stateful systems with positions and velocities, and decisions by one agent to change their behavior changed a signal that was incident on another agent, like the distance between the agents, or if they're trying to avoid collision, that was really important. Your behavior of another agent might actually be contingent on a change in state caused by the first agent, and that sort of statefulness creates feedback paths. In the sense, the actions of one agent change the state of the system, influence the incentives or the rewards, but also the state of another agent, and actually can sort of steer the overall behavior, especially when those interactions are governed by some conserved natural laws. We're all very comfortable with conservation of energy. It turns out that you can code sort of arbitrary notions of conserved quantities. If you impose those in a protocol, you're able to specify some form of constraint. And this is the sort of complement to the incentives as objective functions thinking. If you create constraints through natural conservation laws, you can actually achieve both the sort of evolutionary properties that we need to find solutions that we wouldn't have thought of on our own to start with, but also the sort of protection against evolution towards undesirable states, or generally move the system in some unknown direction, while also not causing, we'll say, some damage somewhere.
Yeah, and this is actually a point not to be underemphasized, right? Like just as when you're designing optimization systems, if you don't have the constraint set up, or the design space is too general, then you can end up in a very bad corners of the space, right? I used to design genetic programming algorithms to synthesize analog circuits. And it was really easy to come up with an analog circuit that looked like a Rube Goldberg machine. And you try to add constraint after constraint after constraint, and it just would keep coming up with garbage. So it's really hard to specify the actual intent to a computer. And this is the case for genetic programming and more generally evolutionary algorithms, but it's also the case for blockchain. So, for example, Satoshi, when he was setting up, saying maximize the security of the network, I'm pretty sure he didn't have the intent to start eating up the electricity of the planet, right? Bitcoin is now eating up more than 1% of the electricity of the planet. By mid next year, it's on track to use more electricity than all of USA, right? Pretty sure that it's an unintended consequence. It's sort of like a paperclip maximizer come true. So there aren't perfect answers to this, but some of the methodologies that Zargham is talking about really matter a lot. And the good thing is there are structured ways to approach designing evolutionary algorithms where you are writing down the objectives and constraints in a thoughtful fashion. You're thinking about the design space to go for, and then you kind of execute on that and iterate on it. You figure out ways to verify and creatively and so on too. And I was thinking, like, there's a couple books on this from the evolutionary algorithm space too. They're not as famous, but they're really practical. One of them is called How to Solve It: Modern Heuristics by Zbigniew Michalowicz. And there's another one called The Design of Innovation by David Goldberg. And both of those are sort of engineering methodology type approaches to designing these evolutionary algorithms. And I was recently re-reviewing those. And it's like, wow, what we've been doing in this new token engineering movement to sort of apply engineering ideas towards designing these tokenized ecosystems. The thinking is very similar to what these guys are doing in these books. And I'd read those books years and years ago, and I realized that they had a big implicit influence on me more recently.
So I worked on a lot of systems that were optimization based, applied over networks. In fact, my dissertation was on on optimization in networks, and I taught the convex optimization course at Penn for a year. And one of the biggest things that I learned was challenging for people coming from different, not from that area of expertise, was that optimization problems fundamentally, they will like consume every possible resource that's not constrained. So you have an objective and it will achieve that objective at the cost of anything else. And when it comes to networks, this means that the structure being enforced through constraints is really important, because if you have a system, and this includes blockchain-enabled systems, where you don't protect the structure through some form of constraints, then eventually that optimization objective will sort of hit diminishing returns, and the bots or agents will start looking for ways to sort of increase their objective, and they'll start to find ways to cannibalize the implicit structure of your design if you don't protect it. So I think, as a complexity scientist, the kind of working in this space, one of the questions is, okay, what is the structure of my system and how do I protect it so that even as my agents optimize and find new ways to make the system better, they can't do it at the cost of something that's required for my system to be the system I intended it to be. And that can be a little bit nuanced, because we tend to, as humans, really focus on our upsides and not our downsides. Like, we imagine all of the best possible outcomes. We don't always examine the ways in which what we've created might, sort of break.
Yeah, I'll just jump in there for 1 second. I think that's a great point. And it really gets to the question of design, how design is so important in these systems, and putting in the right values into the network at the beginning, right? Designing the right parameters, the right values into it. Because actually, if you generalize what you just talked about there, like, that's a problem in economics and society in general. Think about like the modern corporation, right? That was designed to optimize for value, for financial return to shareholders, and the kind of problems that's created in our world, right? And now we kind of have to shift to kind of a broader spectrum of values to get corporations to work in a way that's functional for society and for economy and so forth. And that's exactly the same for what we're designing here, isn't it? It's like if we just optimize these, whether it's the same for AI and blockchains, isn't it? Because they're both kind of optimizing for something, and you have to get the right values into them if you want the right outcomes. And if you miss some parameter or some value that's not baked into the network, that is actually out there and real in the world, like I don't know, you could like Bitcoin, it's just kind of, it's optimizing. It's not factoring in the electricity that it's burning into the whole equation, and that's why you get that negative externality. So I think that's a huge issue, isn't it? Like designing in the right values into the system so that you don't get the negative externalities.
Yeah, it makes me think that there's probably a list of unintended consequences or disruption that could happen. And I'm sure both you, Michael, and Trent have thought about some of those. Is there any others? I mean, energy's huge. I was just listening to NPR this morning on my way into work, and they were talking about how much energy this is going to require. And so that's
Just Bitcoin alone.
yeah.
Yeah.
So that's clearly
Yep.
one. Is there any others that come to
Well,
mind? And how are you getting ahead of some of those?
Well, some of the examination of externalities that I've done has been in conversation with a project called EXO that's actually looking at sustainable development, and in fact, they're talking about tokenizing a variety of impacts that one can have on sort of sustainability, favorably largely. But one of the things that we realize right away is that even if you start tokenizing and viewing that as a form of production, sort of having a positive environmental impact, you immediately run into issues with the commoditization of those impact measures because they're not unconnected. So you might be able to make an improvement in one area at the cost of another. We look at people driving electric cars that run on power that's generated from sort of fossil fuel based. Like, have you really made an impact? Well, kind of. That would be better if we also did this other thing. And so some of the discussions with their team have been around the interconnection between the measures of impact and what does it actually mean to have the collective production be better, as opposed to just commoditizing the individuals and having that be essentially so financialized that we end up in the same boat where we just like, oh, these are now viewed as assets. How can I, make as much assets as I can? And again, losing track of the whole point of sort of tokenizing that impact in the first place.
Yeah, and agreed. And sort of a way to generalize on that is with incentives, you can have intrinsic incentives or extrinsic incentives, and tokenized ecosystems. By paying you in tokens, if you do something that the system finds a value, that's very much an extrinsic incentive, right? But if we think about, 6-year-olds in a classroom, every time they answer a question to the teacher doesn't give them candy, right? And you don't want to do that because that would sort of teach them sort of these extrinsic incentives around learning, where you want them simply to enjoy learning by providing a good environment for them and removing all the negatives as much as you can, right? And so it's a really big challenge. Overall, in blockchain land, we're getting better at the extrinsic incentives, but in terms of intrinsic, we're barely anywhere at all, right? And a good example, a specific example, is things like reputation systems, right? If you tokenize reputation directly, then that can cause all sorts of problems because people are going to game it in crazy ways. And the negative implications of that are like people could be living and dying by reputation. Cory Doctorow wrote this really wonderful book called Down and Out in the Magic Kingdom about 10 years ago, where reputation was tokenized, and it was a disaster. This token called Woofy. People have been working on things where you have sort of localized versions of reputation and whatnot. I think that's really important, where you only have reputation within a particular context. That way you can switch contexts and sort of have a fighting chance. And more broadly, try to find things that where you're not explicitly measuring and incentivizing a reputation directly. So this is one example, and the more broad challenge is, how can we use blockchain technology or other techniques to help towards intrinsic motivations?
So I want to go kind of even bigger picture on this topic because we talk a lot about building systems and blockchain technology and platforms. And I think that there's almost this human bias towards imagining one of those to sort of everyone to use, which completely defeats the purpose, right? Because context dependence is about having, heterogeneous world of all of these different options and environments and communities, like communities of communities. And we tend to think of things being decentralized the moment that we bring decentralized technology to bear, but we talk frequently about, like, being the one platform, or people talk frequently about being the one platform, and actually achieving decentralization at the information and at the communities and the sort of real world level actually necessitates the opposite of that. We need to have, localized environments in which you can have potentially a tokenized reputation, but you can vote with your feet if you're in that environment and, you're not able to sort of thrive in it. You move to another one, and that's not able to be held against you because it's not one big platform. It's a different piece of the world. And so this notion of heterogeneity and, in fact, asymmetries are really important concepts in true decentralization. Asymmetries in the sense that if we, again, have one notion of value in the world, there's no way for us to have a net value interaction, net positive value interaction. So asymmetries are actually very important to having sort of more organic, like efficient and like healthy systems. And obviously you can hear in this we use a lot more organic terminology and less mechanistic terminology, because building decentralized systems is actually a lot like building, biological or ecological systems than it is like building machines.
Yeah, and to kind of riff on, oh, sorry, go ahead.
Oh, no, I was just going to ask how you bring people along in that, because I mean, even Haley and I were in the complexity thinking world. We're not complexity scientists.
No.
But we're in this space, and so I feel like most days we get it, and then every so often we go, "Are we getting it?" And so how do you bring society, and thinking of a global society, along in this journey, and how do you get that buy-in, and especially to those that may not have access to technology or to the language and all that? How do you go about doing that?
Kind of my view is help them directly, one problem at a time. Most people in the world don't know about databases. They've never heard of, TCP/IP and so on, and that's okay, right? But they do know that they can talk to their friends online somehow, right? They do know that they can, go to another country and work remotely and send money back to their family, where in the country where they're from. So figure out ways to help humans directly, one problem at a time, towards sort of this incentive for the global good, et cetera. And that's it. To me, the goal is not for the whole world to be deeply aware of every aspect of blockchain technology, right? Just like they're not deeply aware of database technology or, the levels of the internet stack, right? That's not necessary. It's really about helping people to improve their days. And ultimately, if there's sort of an overall KPI for this all, it's self-actualization of civilization. And what I mean by that is going towards a world where every single human on the planet has an opportunity to self-actualize. The barriers are removed, so it's not just getting by in sort of a basic income type approach, but having the barriers removed such that they have every opportunity to self-actualize according to whatever that means for them, right? Maybe that means, doing science. Maybe that means doing yoga all the time. Maybe it means playing video games all the time, and it's really up to them. And to me, that's sort of the ultimate ideal, and kind of trying to find ways to get to there. And blockchain technology is part of the path. AI can be part of the path. A lot of ideas that aren't technology related at all are part of the path, and it's this combination of things that we can do together towards that overall goal.
So I'm going to jump to what we're talking about in the side channel in a second, but I wanted to point out paths towards this. And obviously we're just starting to break paths, but my analogy earlier about sort of semiconductor level technology and microcontroller level technology, and then the sort of all of these complex real world machineries that we have that we use to do things. Again, humans don't understand that there are 50 odd microcontrollers in their car. It comes to this path from how do we get from these low level technologies that we're starting to get get invented that allow these digital systems to have those properties too, to things that humans can appreciate. And I tend to break this down into something I call a value stack, which sort of pushes this sort of software at the lowest level that allows the peer-to-peer networks to exist, and then the peer-to-peer networks, which are themselves communities. Even if they're communities largely of bots, they're bots, generated by human real-world business entities. Those networks in turn provide the substrate for what I call interaction patterns, which are, they're supported by smart contracts potentially, or other software. They're the means through which agents in a level above can interact with one another. And then above that, you actually have the sort of emergent economy or ecosystem that lives on top of that stack. And we can imagine having lots of those all interacting with each other. So sort of that's not the whole world runs on one stack, but many of these stacks are interwoven with each other to collectively realize this sort of community of communities in which a large degree of interaction patterns are exposed, through which people can exchange value with one another, or essentially do what they want to do in exchange for whatever someone else is willing to reward them. And even in the case of the person who plays video games all day, if that video game playing generates data and we take the data as labor paradigm, then that person could actually be getting paid for that, provided it creates some utility somewhere for someone. And I think that's sort of our path towards this self-actualization idea. It's a long path, but it's nice to be able to see some guideposts.
Yeah, and kind of relating to that sort of, one sort of meta narrative that Michael and I talk about a lot, and, it's sort of a small but growing community within the blockchain space, is this meta narrative around this idea of nature 2.0. And so to unpack that, nature 1.0 is everything around us, right? The soil and the wind and the trees, where, a given tree, it's taking in CO2 and moisture and some nutrients, and then manufacturing wood and oxygen. And it doesn't really have a sense of identity or a sense of scarcity. It just is. It's there, but then it's actually providing this service to the planet as part of a narrow ecosystem, and as part of broader ecosystems as well. And same thing with the flora and fauna around it, and then these larger and larger ecosystems, all sort of like hierarchically composed. And so that's sort of nature 1.0, if you will. And it's sort of this cradle of civilization. It's what we all grew up on for hundreds of thousands, millions of years, right? And so the nature 2.0 simply adds silicon and steel, if you will. Once again, though, it's sort of these public utility networks. It's providing a service to humanity, where you might have, say, a single self-driving car driving around, but it's actually self-owning. It has, no real necessarily a concept of identity or anything. But once it's paid for itself from its manufacturer, maybe all of its surplus does go towards some sort of universal basic income or otherwise. And not just with one self-driving car, but a whole swarm of them, driving around. And same thing with fleets of self-driving trucks. Same thing with roads and electric grids, et cetera. So overall, we end up with this sort of new layer for civilization that builds on top of nature 1.0, using silicon and steel, or maybe replacing silicon with carbon as we get better at that too. So, and that to me is sort of a hopeful dream that we can work towards. And AI can help to provide the abundance by making things a lot more efficient. And then blockchain can help to provide the connective tissue among all of that, as well as the incentives to get there. So to me, this is overall sort of one of the building blocks towards there. And part of the reason that we're building Ocean in the near term, it's really about helping to, remove the sort of centralizing tendencies that AI has right now with the data silos. But part of the longer term goal of Ocean is to actually help to make it really a lot simpler for people to build these nature 2.0 type scenarios with, machines providing abundance towards humanity.
Thanks for you had us going, ha, over here while we were muted. Thank you for chiming in on that. Joss, you're going to mention something about trust, and we bring up that over to you, Joss, to address that, and then I'm going to pass it over to Haley to bring in the online conversation. There's a really rich conversation that's going on there. So as we wrap up, we'll bring in that online conversation and some final thoughts, and then our next steps. So Joss, over to you. Something on you want to mention trust and identity?
Yeah, for sure. So yeah, I think that gets, like, the idea of trust kind of gets the bigger the bigger issue here surrounding what I'm really interested in is like the transition kind of from hierarchical institutions to networked institutions, and how we make that transition, and how technology enables us to make that transition. And so that's been a transition that's been happening now for like, I don't know, since the middle of the last century, you know. And it's gone in kind of in waves as technology has developed. We went through kind of that platform revolution with Facebook and eBay and Uber and all of that, and that kind of built networks. But they're still quite constrained. And now we've got a whole new set of technologies. I think this is the whole new stage in that development of building networks and replacing hierarchies with networks. And trust is a big part of that, because what the blockchain really enables us to do is actually builds intra-organizational networks. So it's no longer, before the hierarchies were all about organization internal to these closed boundaries, right? Where you could have trust, where you could have that single database. But you couldn't really trust people out there in other organizations. You couldn't trust other individuals, and you had no shared source of truth. And that's why we couldn't really collaborate across whole economies, across whole industries, across the whole of society. And then when you get this technology where you have a shared database and it can be trusted, it's like you can really network across a massive group of people, even across the whole planet or across whole economies, you know. And that's a key aspect. That's why trust is so important, because it enables us to collaborate with people we don't. Well, that's why blockchain is so important, because it enables us to actually collaborate with people we don't know, we don't trust. And you can just kind of do that in a very modular, small little bits, contributing little bits. And the other thing is, it's not just trust, it's also about information, a shared source of trusted information. So we can have like a single source of truth, right, that we share between many different organizations. And that enables us to actually kind of come to consensus about the state of things. Whereas before it was all like each organization had its own kind of source of truth, and we had to kind of continuously kind of negotiate that. And that's why it was so difficult to get kind of massive collaboration on a kind of global scale, right? Because it was just all these centralized organizations. And that's what's so important about blockchain. I think it enables that kind of huge collaboration between these centralized organizations, between nations, between people on a massive scale.
I think the thing that's most important from my perspective is that we have trust in the sort of state of the world, right? We interact, or we interact, we react or respond to the state of the world when it comes to collaboration. And I would say in most instances, we really haven't removed the need to trust the parties on the other end of our transactions, but we've created sort of, through cryptography, we've created sort of locked pipes where we sort of know that, you know, nothing's going to go wrong in between. Instead of using a third party to facilitate the sort of the transaction, or to facilitate the sort of exchange between two parties, now we have this sort of information technology that sort of plugs all the potential holes outside of just trusting the person or the entity that I'm interacting with. And that trust can come about in a variety of different ways, but I think that it's actually coming about in a very natural, sort of almost, you know, organic way. It's trust based on communities. If you participate in the same community, if people know who you are, so to speak, and I don't mean in the sense that you have an absolute global identity, but even just that you have a participation in a community, then your ability to interact with others in that community is in part governed by the fact that you trust that community. It's interesting, the discussion. The word trustless is often used, and I tend to push back on it, because I think more than anything, the technology moves the trust around. It moves it around in a good way, because it allows us to organize our systems in a way that is a little bit more community-based and a little bit less sort of centralized authority-based.
Yeah,
Excellent.
so to riff on what Michael had said, you could say that, you know, there's a cost to coordination among humans, and the traditional way is, with humans you don't know, you have to pay for that trust, right? By paying banks or whatever, you know, $40 to do a wire transfer or something, or you have your limited social group. But now with blockchain, you can actually at a much lower cost coordinate with much larger groups of humans, right? And so what Nick Zavos calls this social scalability. So blockchain technology allows sort of society to get to a next level of social scalability simply because of the technologies that Zargham talked about, et cetera. And I think that's a wonderful way to frame it all overall, right? It's not about trusted versus trustless. It's just about scaling our ability to interact with larger and larger groups of humans.
That's definitely a shift in the mindset, a different way of approaching things. I'm excited to see where things go. I'll be honest, there's a little bit of me that's like, where's this going? You know, that uncertainty always brings a little bit of curiosity and also that little bit of fear. So,
Yep.
but I'm definitely more curious than anything. So I really appreciate you all both being on this Complexity Live. It has been fantastic. Before we wrap up, I want to pass it over to Haley. Do you have any highlights? You have a really rich conversation going on with the online community. On the online chat, do you want to bring any highlights in or any ahas that you've had over there?
Yeah. In the beginning of the chat, there was a back and forth conversation that happened around the notion of inequality.
Mm.
And it just made me think about, we're designing these systems and we're as ecosystems, and our frame of reference is what we have in our society today. So that you kind of touched on that a little bit, Michael, when you were talking about asymmetry and how we need that, and it is important in complex system science. So designing these systems, knowing that that's going to show up and be a part of it, and hoping, but I think we want to have a more positive outlook for how this technology is going to unfold. So I don't know if either one of you want to chime in with just a little bit, if you could add to that real quick, and then we can wrap up. Does anyone have anything to say?
Go ahead.
Sure. Well, overall, with any sort of general purpose technology, there's really strong positives and really strong negatives, and blockchain is no different. I think that it, does provide opportunities for more inclusion and whatnot. And the good thing is, because it is about communities and stuff, it seems that the blockchain community is thinking a lot more about inclusion and equalizing opportunity a lot more than, say, the SaaS community, which is actually, really fun. That said, if you think about nature itself, nature gives as sort of this cradle of civilization, but nature also can be brutal, right? So, and evolution itself. So, we should be expecting that there's going to be really wonderful things that emerge, but really dark things too. And what we should be trying to do is do our best to help to catalyze the wonderful things and mitigate the effects of the super negatives.
Yeah, I was going to talk more about. It sounds like the discussion was in the direction of inequality, and I think that if we think of it in the financial sense or in the traditional paradigm, we see the accumulation of wealth in a small number of entities, a small number of people. We are definitely seeing that in the early stages of blockchain economies, that there is a high degree of inequality. A large amount of value is sort of retained in the hands of the early adopters. It's retained, and in some ways, I view this as a consequence of us still thinking in the sort of financialized paradigm, right? People talk about it as fintech. They talk about, we've made everything into money. And in fact, that's not the paradigm that associates well with sort of Nature 2.0 or more broadly with organic sort of models of coordination. You actually have to break symmetry in the sense that everyone's measure of value is not the same. And once you sort of acknowledge those asymmetries, you actually kind of break down the entire paradigm where someone is accumulating massive amounts of some measure of wealth, but rather things should be flowing to entities insofar as they're valuable to those entities. They're not uniform measures of wealth precisely because someone who didn't value them as high was the one flowing them to you. So I think that the tier one issue is that we're still thinking in terms of financial paradigms. And I can't say that we should just forget that, because it's part of the real world today. And we need to we can't teleport to a future version of collaboration, but we need to be aware of sort of not just the first order change saying, hey, let's distribute this wealth more evenly, but actually like question what we're using to define wealth so that we can handle those problems concurrently. I think in the meantime, we absolutely have to handle wealth distribution, but that we also need to recognize the limitations of that paradigm.
To riff on Albert Wenger, we want to move to a world after capital.
Oh, I like that. That is a up on. I like that a lot.
Yeah.
Thank you. And to wrap up, I'll pass it over to you, Trent. Do you have any announcements, and how can our viewers learn more about the work that you're doing?
No announcements offhand. I mean, you know, next week in Berlin, there's going to be the Web3 Summit. So there'll be a lot of the thought leaders and builders, especially the builders here in Berlin, including Zargham. So it'll be great to have him here for the Web3 Summit, as well as a token engineering global gathering that, you know, it's a movement that Zargham and I and several others have been working to catalyze and grow so that there is this growing sense of not just theory, practice, and tools, but also responsibility in terms of engineering these tokenized ecosystems. So to learn more about Ocean, probably a good starting point is oceanprotocol.com or at Ocean Protocol on Twitter. And then for myself, probably the first point of contact would simply be on Twitter too, at TrentMC0. So you don't have to spell my last name, it's just at TrentMC0. That's all for me.
Thank you so much. Thank you so much for taking some time, Trent, to be on Complexity Live. And Michael Zargham, any upcoming announcements, anything you want to share, and how can the viewers find you?
Well, I'm also reachable on Twitter, though you have to be able to spell my last name. I'm at mzargham, Zargham. In terms of announcements, my firm largely does its research sort of in-house. We're looking to do some publications, but we're still a little small, and we don't have any grad students because it's a private company. But I will be in Germany this week and in Prague the following week, and with members of my team. I have a Medium account and a website. It's block.science. Please, reach out to the BlockScience team via media@block.science. And I hope to have more to announce sort of public research in the coming months as the team continues to sort of grow and sort of make progress.
Excellent. Thank you. Thanks for spending some time with us here too. It's unfortunate that we didn't have Diego and Mihaela join us. So hopefully we'll be able to get them on at some other time. Haley, do you want to give some announcements before we pass it over to Joss to wrap up? Any announcements for us?
So I cannot add any of the links that we shared in the actual live chat that we're having, but I will paste them in the bottom of this video when we're done here. So this video stays up on the Complexity Labs YouTube channel, and I'll add those links for everybody. As far as the HumanCurrent coming up, we have some really exciting events, interviews. Today at 4 o'clock, we're interviewing Laszlo Barabasi, network scientist. And so we're super excited about that one. We're hoping to get his interview out just before his book is released. The formula releases on November 8th. So stay tuned. We're going to talk all about his new book. And recently, Angie interviewed Linda Booth Sweeney, systems thinker and definitely a pioneer of educating young ones about systems thinking. So that was a great interview. We're excited to share that one as well. Yeah.
I think that's it for us. Joss, we'll pass it over to you and to close us out. And I want to give a thanks to all those that joined on the chat live and to our featured guests. Thank you so much. Joss?
Okay. Yeah, so if you want to find me, then just stay tuned to this channel. You'll get me here. Don't worry, you're in the right place. I think what Michael said there at the end actually kind of was the thing that I wanted to say, that we actually need to think differently about this technology, these economies, these token economies, and just bringing the old ways of thinking and kind of plonking them on top of this is quite destructive in some ways. It just accentuates a lot of the problems we had in the past of financialization and inequality and so forth. And really, systems thinking, complexity thinking is really what we need to bring this technology alive, to use this technology to bring those ideas out into the world, of self-organization, of emergence, of decentralized coordination, and so forth. So that's what's really interesting about this whole technology for me, that there's such a good mesh for those two things. And I think the two kind of communities, the complexity thinking, complexity theory community and the blockchain community, really need each other as much on the technical level to design things as on the kind of conceptual level to just look at things differently, to think holistically, to think in terms of emergence and self-organization. And that's actually something I'm really trying to promote, trying to get those ideas from complexity theory more into the blockchain world, so that we can look at this and really use this technology to enable something different, not just the stuff we did in the past, not just take the ideas from the past and plunk them onto the future. We can actually kind of think differently and really build different different kinds of organizations, networked organizations, where we push resources out to the edges, out to the people, and then coordinate them through self-organization and emergence and so forth. So that was I guess that's the one point I wanted to make in this whole conversation. But it's great having you guys. Thanks a lot for joining us, and we'll do it again sometime.